Hello, everyone. I'm Imane Karkaba, a PhD student belonging to Data for Earth Laboratory, Faculty of Sciences and Techniques from Morocco. First of all, I would like to express my gratitude to everyone interested in our concepts and finds it useful. In this video, on behalf of my colleagues, I will try to demonstrate and clarify the way we conducted our study, of which the title is Marrying Deep Learning within Blockchain Technology for Credit Card Fraud Prevention. It has to do with the fusion of one deep learning model within blockchain technology for the sake of intensifying the efficiency of credit card fraud prevention system by breaking down the process all the way through towards the final result that is represented in a simple prototype that automatizes the process of verifying the authenticity of credit card transaction using a trained deep learning model and making it consumed in a decentralized immutable database called blockchain. Here are the points I will shed light on in this video. I will start with giving you an overview about the targeted issue, as well as I will discuss to what extent the previous works are significant, and also I will define and present our contribution. All this under the umbrella of the introduction. In the second part, I will talk briefly about the deep learning model or the adopted deep learning model. Then the crucial part embedded in blockchain, where I stress the blockchain concept and its functionality in order to better understand the architecture of the proposed system, targeting the deployment of our model as a fourth part devoted to explain the components of the system, and the fifth part in which I will clarify the implementation of our ecosystem in a web interface for monetizing the provided service. Finally, I will close this video with a conclusion. Okay, let's start. As you know, today credit card fraud has extremely grown. This refers to the excessive use of online and mobile payments so that it's easier for scammers and fraudsters to make and conduct fraudulent transactions remotely. These criminal acts lead to financial losses for both individuals, or we can say also cardholders, and financial institutions or merchants. Cardholders may be held responsible for unauthorized charges, and merchants may lose money if fraudulent transactions are not caught and reversed. For this reason, it's inevitable and necessary to implement effective measures to prevent credit card fraud for protecting cardholders and institutions from bankruptcy by, of course, detecting illegitimate interventions and banning them. So, for the significance of the previous works, and here, in the attempt to predict, detect, and prevent menaces, scientists have proposed a plethora of approaches. Data mining, machine learning, and deep learning are deemed to be the most significant techniques because they are characterized with their detection system efficiency, especially when dealing with vast complexity matters. In spite of the varied systems and frameworks have been employed and deployed, many shortcomings are still emerging. The frequent limitations concern mostly imbalanced data, adversarial attacks, real-time detection, data confidentiality, etc. Okay, so let's focus on one limitation to pass briefly. For example, building real-time detection system becomes complicated in sectors with huge transactions and giant datasets. Therefore, any minute delay in fraud detection can lead to financial losses for individuals and institutions. For identifying the gap, we have assessed numerous credit card fraud systems, and we inferred that they possess pros and cons. the thing that allows machine learning and deep learning algorithms to excel in detecting one class of data but struggle with others, or they may perform well in a specific system and fail in another. Apart from the common purpose of the majority of the proposed methods is only to detect fraud in new transactions. So, in the view of these shortcomings, our contribution is embedded in consuming a deep learning model in blockchain technology for many benefits. And our main motivation behind using deep learning and blockchain together is that they can enhance the accuracy and effectiveness of fraud prevention because of the following factors. First, deep learning algorithms can analyze large amounts of data to identify patterns and anomalies that may indicate fraud. Second, blockchain technology can provide a changeless, secure, and transparent record of transactions. We will see how blockchain can provide these benefits in the next upcoming slides. For this reason, our prototype is believed to be more resilient and robust in both detection and also in prevention. And here is the time of shedding light on our double key method. In other words, to provide you with more details about this amalgamation or combination. For our deep learning model, the selected algorithm is autoencoder. It's a type of artificial neural network that is commonly used for dimensionality reduction and future learning. It consists of two parts, encoder and a decoder. The encoder maps the input data to a lower dimensional representation, and the decoder maps the lower dimensional representation back to the original input space. In the context of detecting fraudulent credit card transactions, an autoencoder could be trained on a dataset of normal, non-fraudulent transactions. The encoder would learn to compress this data into a lower dimensional representation, and the decoder would learn to reconstruct the original data from this representation. Once the autoencoder has been trained, it can be used to detect fraudulent transactions by comparing the reconstructed data to the original input data. If the difference between the two is large, this may indicate that the transaction is fraudulent. Autoencoders can be effective for detecting fraudulent credit card transactions because they can identify patterns and anomalies in the data that may be indicative of fraud. They can also adapt and improve over time as they are exposed to the new data, making them more robust and accurate over time. So the option fail on this algorithm as it doesn't need a data set modification, allowing us to surpass the imbalanced data issue. More than that, our model has demonstrated promising results as you see here. And if you take, for example, F1 score as a metric of evaluation, it has reached a 93% in the classification case. So here is the most important part to simply define blockchain. It's a decentralized, immutable database that stores a record of transactions. It's a type of distributed ledger that is secure and transparent. One of the key features of blockchain technology is that it allows the transfer of values such as cryptocurrency, assets, or even data directly between parties without the need for a third-party intervention. This is because the blockchain is a decentralized ledger that allows multiple parties to reach consensus on the state of the ledger without the need for central authority. Transactions on the blockchain are secured, and it's difficult for anyone to alter the records once they have been added to the chain. In the other words, neither modification nor deletion of a transaction can occur even by a system administrator. Each transaction is recorded as a block, and these blocks are linked together in a chain, hence the name blockchain. The immutability of the blockchain is achieved through the use of cryptographic techniques, which make it extremely difficult to alter the records once they have been added to the chain, because every block contains the hash of the previous block. So if you change something at the level of the block, the hash is changed as well, which will lead to change the next block. So if you want to change a block, we have to change the entire or whole chain. This makes the blockchain a secure and reliable way to store and transfer data and assets. In addition to storing transactions on the blockchain, we can store code. This code is smart contract. Smart contract is a digital agreement. It automatizes the execution of contracts, and once it is deployed on the blockchain, it can't be changed or altered. For example, if I make a smart contract that I will give some money to someone, once some conditions are fulfilled, as soon as they get fulfilled, the contract is executed automatically and smoothly. For our model deployments, the model deployment or the deployment of our model involves or contains the deployment system and our implementation. So, after understanding the basic components of our solution, here is our prototype architecture that I am going to break down by explaining each mechanism and its functionality in this ecosystem. First, we have the blockchain network. We use Ethereum blockchain to conduct this experience. We use it because it enables us to use smart contracts, and as you will see, the smart contracts will play a key role in our prototype, in which we will try to integrate our model in it. But the main hurdles here is the smart contracts, which can't use directly external data out of the blockchain. I mean our deep learning model. And the most challenging step in this process is integrating the model into the smart contract. After a long journey of researching, we found two ways to do so. The first one is to convert the entire model after training it into a suitable format that can be deployed on the blockchain. Second way is there is another decentralized network composed of nodes called oracles, namely Chainlink, that can provide off-chain data from external sources. So the idea is to make an API in the jargon of Chainlink called external adapter and deploy the model in it and use only the result of the prediction and transport it all the way through Chainlink to the smart contract. It was the hardest step because it requires a good understanding of the technical aspects of deep learning algorithms and the blockchain technology. Then, the last part is a website designed to make this system in action. It is like credit card fraud detector that will be used by banks to verify the transaction, then it's flagged and legitimate or fraudulent and stored on the blockchain in a way that can't be altered or tampered. And here the blockchain plays the role of a preventer. On the other hand, the use of our service requires paying some ETH or some coins. For our implementation, this is the front page of our ecosystem, as you notice here. And you see here a bank that is identified by its address wallet. Here we put down the transaction information. Then, after verifying the transaction with our model, the result is sent and the transaction is saved. And here again, the bank had to pay some coins and its. And here, on the other hand, we can withdraw the coins gathered by our smart system. That's all. And to close this video, I can say that we have seen one way of combining artificial intelligence and blockchain that is a powerful combination, especially to improve security, integrity, and transparency. And also, this work has triggered our interest for further experiments to be undertaken, which might concern fusing more sophisticated algorithms beyond traditional deep learning, for example, so that we can reinforce privacy, ameliorate robust testing environments, and sustain the security of blockchain system. Thank you for your attention and hoping you find it fruitful and was clear enough to get something new. Thank you.